Okay, today is lesson 4.5, quadratic relations in the form y equals a, x minus r, x minus s. That is factored form, but before we jump into that, I want to quickly review what we have here, which is called vertex form. Vertex form. You don't need to take these notes, you just need to pay attention really quickly. We're going to summarize what we know from vertex form. Somebody please tell me what information we can get from H and K, considering the name is vertex form.
Horizontal movement and vertical movement.
H moves at vertical, K moves at...
So we're getting our horizontal and vertical translations from H and K, but what we want to remember right off the bat, super easy. When you get vertex form, the vertex literally is just HK. So if you want to talk about translations and you don't know where to move your parabola, you just look at vertex form. That's the x-coordinate, that's the y-coordinate. You'll know exactly where to put your vertex before you start drawing your parabola. Okay? Vertex form gives us the vertex. So it's named after what it tells us. Good. So you've said this is our horizontal translation. This is our vertical translation. What else does this form give us? What does A? A gives us our vertical stretch or compression. Okay? H and K move it around. A tells us the shape. Vertical stretch or compression. Excellent. The next form of an equation that we're going to be learning about is called factored form. Factored form, we still have A, and this A does the same thing as that A. It tells us the stretch compression. But then, rather than having a squared binomial here, rather than having something in the bracket squared and then adding a constant at the end, we have two factors. We have one factor x minus r and another factor x minus s. And this is called factored form. Factored form. We're going to do a little investigation, a little activity to help us understand what happens in factored form and what information it gives us for free without any work. It's going to give us some information. Just like vertex form gave us the vertex, factored form is going to give us something about this equation, something about this parabola. Okay, so number one on your worksheet there, it asks you to create a table of values for the equation that's given there. We have y equals 2 times x minus 5 times x plus 3. And we're using values of x from negative 6 to positive 6. From negative 6 to positive 6. So I'm going to go ahead and calculate the first couple with you so that we can get good practice on doing it. I'm going to copy down our original here. 2 times x minus 5 times x plus 3. And maybe first I'll just say this is called factored form because it's written in its factors, right? Anything that gets multiplied by something else is a factor. Factors multiplied by each other equal a product. Okay? So this is the factored form because it's been split into 1, 2, 3 factors. If A was 1, then it would just look like this. You'd have 2 factors. Okay. Again, we're filling in this table for integer values of x from negative 6 to positive 6. So let's first look at what happens when x equals negative 6. Well, when x equals negative 6, y equals 2, and then in this bracket I have negative 6 minus 5 because I'm substituting negative 6 everywhere I see x, and times negative 6 plus 3. And then I just perform some algebra on that. I start with brackets. So my 2 stays inside this bracket. Negative 6 minus 5 is negative 11. Negative 6 plus 3 is negative 3. Now I have multiplication. I can do this in any order. I can do 2 times 3 and then times 11, or I can do 2 times 11 then times 3, or I can do 3 times 11 times 2. I usually like to end with my 2 because it's the easiest to deal with in big numbers. So I'm actually going to go with positive 33 times 2, which is positive 66. So in your y column, right beside x equals negative 6, you'll have a y value of positive 66. Okay, I'm going to do at least one more with you here. We're going to see what happens when x equals negative 5. y. I'm going to do the whole thing again, and then I'll do the next one. I'll show you kind of a quick way to do it in your head. But for now, we can just replace x with -5. So we've got -5 minus 5, and -5 plus 3. What am I dealing with first? Brackets, very good. My 2 stays out there. -5 minus 5, and -5 plus 2, plus 3, -2. Excellent, same thing. Here we have plus 20 times 2 equals 40. Now, if you're getting good with your addition and subtraction of small numbers and positive and negative numbers, you can just kind of think about what that bracket is going to be. So let's consider x equals -4. And without really doing it, we're just going to look at our brackets, and in our head, we can say, okay, -4 minus 5 is 9, -4 plus 3 is -1. So right away I can just write my next step. Y equals 2 times -9 times -1. This is positive 9 times 2 is 18. Okay, so we didn't rewrite the whole thing like we did in the first step of our other ones. We just did that part in our head. Each bracket in your head, you're allowed to do the brackets first, right? We have to do the brackets first. So you just write down what your factors are. So you have 1, 2, 3 factors, multiply them together, positive 18. Please go ahead and do the rest of the chart on your own. So this is practice for doing simple algebra and filling in a table of values. And then I will go ahead and print the answers on the board so that you can check. But please do the calculating on your own right now. All x value integers from -6 to +6. Okay, at this point you can check the board and see how you did on the ones that you were able to calculate on your own. And the ones that you weren't able to get done, just copy so that we can carry on. Did anybody find anything they disagree with? Or would like to double check? Or you're not sure, or you want to ask if somebody else got the same as you? Good? Good. So we're going to do a couple other things with this table of values, and then we're going to ask some questions. So we're actually going to turn to number 3 right there beside in the box. It says, identify the x-intercepts. Well, the x-intercepts of any graph, of any parabola, occur where that parabola crosses the x-axis. So for instance, if this was our parabola, I don't know if it is, I'm just drawing any old parabola, the x-intercepts are here and here. What's important about those two places on this graph? There's no numbers on this graph, but what do you know for sure about this point and this point?
One's going to be positive, one's going to be negative.
Okay, so in this particular graph, we know that the x-coordinate here is positive and the x-coordinate here is negative. That's good. But what if I drew it like this? There's still something that's true about all 4 of those points.
They're on the x-axis.
They're all right on the x-axis, which means, what about their y-coordinate? Their y-coordinate is always 0. So wherever y is 0, we have an x-intercept. So go ahead and look at your table of values. Find the places where y is equal to 0. And note that those are your x-intercepts. So for 3, you have an x-intercept of x equals what? What's your first 0? Where x equals -3, you have a 0. And where x equals 5. So those are your x-intercepts, because that's where y is 0. Y is 0 at -3, and y is 0 at +5. That makes those your x-intercepts. Okay? Can't forget that. That is hugely important, because now what we need to do is it says, how do they relate to the equation? So in number 3, you have x equals -3 and x equals 5. Look at the original equation.
They're the same numbers. Or
Okay?
Okay.
So,
They're opposite reciprocals of
no, let's not jump ahead and use confusing words. Reciprocal means it got flipped upside down, so we can't use that word because nothing's getting flipped upside down. But look this. I'll draw it again. You've got y equals a times x minus r times x minus s. And in this problem, for our table of values, we were given 2 times x minus 5, x plus 3. What can you say about the x-intercepts given this information? Give you a hint. The sentence starts with the x-intercepts are. What are they? Look at this. X minus r. X minus 5. X-intercept 5. One of the x-intercepts is r. Over here we have x minus s. X plus 3. X-intercept over here at negative 3.
2.
The other x-intercept is s. The x-intercepts are r and s. Yeah? Good. Let's look at number 4. Number 4 says, identify the coordinates of the vertex. Identify the coordinates of the vertex. How could you use the x-intercepts to find the vertex? So first of all, let's identify the coordinates of the vertex. Well, the vertex is either the highest point on a negative parabola, or it's the lowest point on a positive parabola. So which direction is this parabola going? As we go out to positive x and out to negative x, which direction is the parabola opening? Yeah, it's going up, right? Our numbers are getting bigger and bigger as we move down to the negatives, and they're getting bigger and bigger as they move to the positive. So we know opening up, we know our vertex is going to be somewhere down here. So let's find it. What is the lowest point on your grid? Well, now we need to look at our y values, find our lowest y value. Yeah, our lowest y value is right here at negative 32, and the corresponding x value is 1. So the vertex, coordinates of the vertex are 1, negative 32. It's the lowest point on the graph. 1, negative 32. How could we use the x-intercepts to find the vertex? Here's our x-intercepts, remember? Negative 3 and 5. And our vertex happens where x equals 1. So how could we use our x-intercepts to find our y-coordinate or our x-coordinate of our vertex? I'll give you a hint. Parabolas are symmetrical. Any ideas? Girls in the back? Any ideas? I can draw it out for you a little bit. What will be true if parabolas are symmetrical? Well, that means our line of symmetry will go right through the vertex. Our line of symmetry is what cuts the parabola in half, so both sides are the same. So that means the x-coordinate of our vertex is just as far from this x-intercept as it is from this x-intercept. Does that make sense? Because it's symmetrical, it has to be that way. It has to go down just as much as it comes up. So the vertex must be right in between our two x-intercepts. So then all we're doing is finding the mean of our x-intercepts. So if we have an x-intercept at negative 3 and one at 5, and we find the average of those, we'd have negative 3 plus 5, that's positive 2. 2 divided by 2 equals 1. So now I know the x coordinate of my vertex is 1. Tells you exactly where the vertex is. 1, and the y coordinate, negative 32.
Okay. For whatever, I just looked at.
Good, let's look to our first differences. Let's go back to our chart. And you have a column there for first differences. Who remembers how to do first differences?
Take the second one minus the first one.
Good, so all we're doing is looking at our y values. We're taking the second one here out of these two, which is 40, subtracting 66, making negative 26 our first difference there. Same thing between these two. We got 18 minus 40. 18 minus 40 is negative 22. 0 minus 18 is negative 18. And go ahead and work yourself down the list without looking. When you get down to negative 30 and negative 32, just be careful. You're doing negative 30 minus negative 32, which is the same as negative 30 plus 32, which is positive 2. Okay, you should have gotten a bit of practice in there. Go ahead and look at my answers and copy what you don't have. Copy what you don't have. And we're going to be looking at second differences. Now, because we know this is a quadratic relation, right? 4.5 quadratic relations in factored form. What should be true about the second differences? They should all be the same. They should be constant, right? We should have a constant second difference. Well, let's see if that's what we get. Here we have negative 22 minus 26. Negative 22, oh, sorry, already an error. Negative 22 minus negative 26. That's negative 22 plus 26, which is 4. Okay. Here we have negative 18 minus negative 22, which is 4. Here we have negative 14 minus negative 18, which is positive 4. And you go ahead and do the rest. Be careful when you get to negative and positive numbers. And just speeding along, of course you found, doing it carefully, that every single second difference was positive 4. That's because we're working with a quadratic relation. Alright, let's go ahead and use all the information that we have to graph our points. You can do that using the table of values and drawing a smooth curve through the points. Think about where you want to draw your axis, your x and y axes, before you start. Okay, so quadratic relations in the form y equals a x minus r x minus s give us some information for free, just like vertex form gave us the vertex. But we're going to see what those things are. So here's some notes. A relation in the form y equals a x minus r x minus s is a quadratic relation. The x-intercepts or zeros, we learned that word on Thursday, I believe. Zeros, they correspond to the x-intercepts, right? It's essentially two words for the same thing, although you use them in different contexts. You don't need to be super familiar with that. They are R and S. Hopefully you have a little bit of room off to the side. You can draw a little coordinate plane with your labeled X and Y axes. We'll go ahead and draw us a little parabola. Draw us a little parabola. All that tells us is that this point right here, it's an X-intercept. The coordinates of this point are R, 0, and the coordinates of this point are S, 0. Good. The vertex down here, the lowest point, the vertex, has the coordinates R plus S over 2. That's the x coordinate, right? It's just the average or the mean of both x coordinates because it's right down the middle. And the y coordinate, we're just going to write y for now. But basically what you would do is you would find the x value and then sub that x value into your original equation in order to find out what y is. And then you would have the two x-intercepts. You would also have the vertex. And you could also find the axis of symmetry, which goes right through the x-coordinate of the vertex. Okay? Well, let's go ahead and use this information. In example 1, it says, describe the graph of the quadratic relation given, and then sketch the graph. Label the x-intercepts, the vertex, and the axis of symmetry. So when we're describing that graph, I'll write down what we have. Y equals 2x plus 1 times x minus 7. All that means is compare it to y equals a x minus r x minus s. So when we're describing it, we're just comparing it to the original empty factored form, standard variables in there, parameters in there. Okay, this is factored form. This is a specific example. So let's see what we see. Somebody put up their hand and tell me the x-intercepts.
1 and 7. No. Or 1 and 0. Do not know.
Do you have a consensus among yourselves?
I think so.
Vlad, give me one of the x-intercepts. You're comparing it to this.
1, probably.
No.
Negative 1, 0.
It's negative 1. Okay? One of the x-intercepts is negative 1, because if you put a negative 1 in for r, you'll get x minus negative 1, which is x plus 1, which is what we have right here. Okay? So one of the x-intercepts is x equals negative 1. What is the other x-axis?
X equals positive 7.
Thank you. The other one is x equals 7.
It's supposed to be hard. Oh my.
Okay, let's find the x-coordinate. X-coordinate of the vertex. Find the x-coordinate of the vertex. What do I do? What do I know about this parabola that's helpful? I know the x-intercepts. And I know it's symmetrical, right? So I know that if I just draw my x-axis here, if I have an x-intercept here and an x-intercept here, then my axis of symmetry is going to be right here. So all I need to do to find the x-coordinate of my vertex is take my x-intercepts and find the average of them. So to find the x-coordinate of the vertex, all we're doing is we're saying x is going to be equal to our two x-intercepts added together, that's negative 1 plus 7, or 7 minus 1, and divide it by 2. That gets us 6 over 2, which is 3. So I don't know the exact point of my vertex, but I know that the x-coordinate is positive 3. Now, how do I find the y coordinate that matches that x coordinate?
Substitute the x into the original equation.
Very good. I simply I know that y equals yada yada yada. All I need to do is sub in x equals 3. So I've got 2 times 3 plus 1 times 3 minus 7. I do my brackets first. 3 plus 1 is 4. 3 minus 7 is negative 4. Now I have 4 times negative 4 is negative 16 times 2, negative 32. So now I know that the vertex, the coordinates of the vertex are 3, negative 32.
Wait a second.
So now I know that the vertex, therefore, the vertex is 3, negative 32. Okay, example 2, Dufferin Gate. So there's this gate in the city. It's a parabolic arch. As soon as you hear that, you know it's symmetrical. You know it's an arch, so people probably can walk through it. So you know it's going to be a negative equation, right? The parabola is going to be flipped upside down. The vertex is higher than the x-axis. And we're told that it's approximately 20 meters tall and approximately 22 meters wide. Okay? So what we need to do in A is sketch a graph of the arch with the left base located on the x-axis 4 units to the left of the y-axis. So that sounds really confusing. All it says is sketch. You guys have a graph there. You know that it's all positive. We said that already. So you pretty much just need yours to look like that. And if we think actually really clearly, we're told that it's only going to get shifted 4 units to the left. The arch hits the ground 4 units to the left of the y-axis. So that's why I'm explaining this. So we've got a y, we've got an x-axis. We are told that it's approximately 20 meters tall. So I'm going to put 20 somewhere up here. And we're told that it's 22 meters wide. And the last piece of important information that we're given is that the left base, so if you're in an arch, the base would be, the bottom. The left base is located 4 units to the left of the y-axis. So here's my y-axis. And I'm going to be 4 units to the left of the y-axis. So if that's negative 4, then I should have positive 4, 8, 12, 16, 20, and that will be enough to draw it.
You said 22?
Is that by every 2 blocks?
Yes.
You think about it and make yours fit. Okay. I'm kind of given my x-intercepts. Well, I'm at least given one of them, right? We said that the base, the left base, was located right here at negative 4. So one of my x-intercepts is negative 4. And we're told that the arch is 22 meters wide. So I'm going to span all the way from negative 4 all the way over 22 meters. So my other one is going to be negative 4 plus 22, whatever that is.
18.
Positive 18. So now I know that the arch comes down here, and I have my 2 x-intercepts. X equals negative 4, and x equals 18. How could I find the vertex?
You take both points and then add them, divide them by 2. Or
You guys are so smart.
We know.
Okay? So to find my vertex, the x-coordinate of the vertex, I'm just going to put a big V up there so you know we're finding the vertex now. The x-coordinate is the mean of my x-intercepts. So we've got negative 4 plus 18 divided by 2. Negative 4 plus 18 is positive 14. Still divided by 2. 14 over 2? 7. So this is just the x-coordinate of the vertex. Now, there's going to be two ways to find, we don't have an equation yet. So we can't actually just sub this in and find the y-coordinate. But didn't it kind of give us the y-coordinate in the question? Didn't it tell us how tall the parabola was?
20.
The arch is about 20 meters tall. So we know we have a vertex at 720.
What's that yield?
Vertex at,
Can you do the
and we can go ahead and add that to our picture. We have a vertex at 720. Your picture is going to be better than my picture. Make sure when you draw from the vertex that you're rounded at the top, curving down. Should look something like that.
Doesn't it go to 22 though? No, that's wide.
No, it's 22 meters wide.
Yeah.
It's 20 meters tall.
So no one goes to
We started over here at -4.
Oh.
So that's how we determined our other x-intercept. Good question. Okay, B. We need to determine an equation to model the arch. So you guys have all that information there. That's great. I am going to erase this side because I only need the stuff on this side to help me. And we're going to determine any equation that will model the arch. Well, we know that our standard equation in factored form is y equals a, x minus r, x minus s. Well, let's sub in what we know. We know that our x-intercepts are -4 and +18. So now my standard equation, if r is -4, then I'll have x minus -4, that'll be x plus 4. And this factor will be x minus s. My other one is +18, so that's just x minus 18. Okay, so I've got a good start. I've got my two factors, but I don't know what a is. Do you remember how we solved for a before? I'll give you a hint. You have another point on your parabola.
it's 720.
We have 720 on our parabola, so we know that the point 720 satisfies the equation. So all I have to do is say when y equals 20, then x will equal 7, and I sub in 7 for x and 20 for y. And now I have an equation where the only variable left is a. So now I can just use algebra, solve for a. Leave 20 on the left for now. Leave a alone because I need to deal with my brackets first. 7 plus 4 is 11. 7 minus 18 is -9. Sorry, -11. So now we have 20 equals a. What's 11 times 11?
-110.
Yeah, close. 121. So we've got -121.
You do twice.
Good. Now to get a by itself. No, they're attached by multiplication. So we're going to divide both sides by -121. So we're going to get a equals 20 over 121, and it's negative. And in order to reduce, we put the negative in the numerator or in front of the number. So now we know what a is. We don't want a big decimal. We're just going to leave it in exact form right now, rational number. But now we know that the equation for this parabola that we drew in step A is y equals, a is -20 over 121. And we know our other factors are x plus 4, x minus 18. Where y is the height in meters and x is the horizontal distance in meters of the arch. Your homework is it listed for you on the bottom?
Yeah.
Yeah.
Excellent. Oh, it's the worksheet, right.
Yeah.
Your homework is the worksheet. You're responsible to know all of it. Please practice with vertex form and factored form.